Good morning, everyone. Welcome back. This is week 5, the very last day of week 5. Almost done with this partial and this school year. So as you can see, we have 6 exercises today, but we're just going to solve the first 4. Okay. Now, we're going to start in a different way this topic. Okay. So as you can see, I have over here a binomial multiplying another binomial. And we are going to solve it. I'm going to solve it with the distributive property. Okay, this one. So I'm going to say x, the first term, times everything inside the second parenthesis. So x times x and x times -2. And also the second term with everything inside the second parenthesis. -2 times x and -2 times -2. Now, before we begin, what can you notice on this specific exercise? What can you say that is distinctive in this exercise?
They are both the same.
They are exactly the same. They are both x -2. Okay, so this is really important for you to identify that they're exactly the same. Okay, so in this case, we're just going to solve it the same way that we did with the previous exercises, okay, with the distributive property. X times x.
2x to the square.
X times x.
X to the square.
Only x to the square without that 2. So x to the square. I'm going to copy it over here. X to the square. Now x times -2.
-2x.
-2x. Now we go with the second part. Okay, -2 times x, which is -2 times x.
-2x.
-2x. And -2 times -2.
+2.
Positive?
4.
4.
4. Very good. Now, look at the middle part. I've always told you that when we have a binomial multiplying another binomial, the middle terms, the 2 middle terms are going to be like terms, -2x minus 2x. So let's make a little pause and let's go down here. What is another way of writing 3 plus 3 that continues to involve this 3? What is another way of writing 3 plus 3 that gives you the same answer? It still involves the 3.
3 times 2.
3 times 2, very good. So, or 2 times 3. It will still be 6. Same thing as if I have -3 minus 3, it is the same thing as saying 2 parenthesis -3, right? Because we're multiplying. It is exactly the same thing. We know that a multiplication is the abbreviation, let's say, of the addition of the same number several times. Well, we're going to do it the same thing, okay? We're going to do this extra step that it is not necessary, but right now I want to do it that way. So I'm going to say x squared. Since I'm taking out the negative, okay, I'm saying minus 2 inside the parentheses. I'm placing the 2x positive because I'm taking out the negative over here plus 4 because I'm doing this abbreviation like I did over here. Okay, and let's solve it. X to the square, -2 times 2x. How much is that?
-4.
-4
X.
x plus 4. So you see, from a binomial multiplying another binomial, we had a trinomial. And yes, I know that you could have added or subtracted in this case from this part, but I need this specific part because I want to explain you something else. Okay, now let's do with this same procedure, this other exercise, okay? X plus 3 times x plus 3, same scenario, okay? We're multiplying the same binomial, by itself. I'm still going to do the same procedure that we did before using FOIL. Remember I told you that this method of the distributive property is called FOIL? I'm still doing the same thing. So I'm going to say x times x squared, right? 3 times x, or x times 3?
3x.
3x. Now I finish with the first term, I go with the other term, 3 times x, 3x again, and 3 times 3,
9.
so plus 9. And we said that middle terms are like terms, and since they are exactly the same term, I'm going to say that this is 2 times 3x, okay? The middle part, I'm just going to rewrite it that way. This is a step that's not necessary. I'm just using it as an example so I can explain the next part, the next step, okay? Exactly, Isabella. Now, x squared, how much is 2 times 3x?
6.
6x.
Plus 9. And this is the final answer. As you can see, this was not easy. This is something that you already know. Okay, now, before I go back to this, if I write x times x, that gives me how much? How much is that?
X squared.
X to the square. Very good. Now, if I say x plus 1 to the square, my question is, can I do the distributive property with the power of a power in that way and say that this is x squared plus 1 squared? Can I say that this is equal to this part over here?
Do what's in the parentheses first.
Okay, but I have x plus 1. Can I do something inside the parentheses in there? No, right? So can I do that distributive property just like I showed you right now in here? I'm going to place this one over here. Can I say that this is true, that x plus 1, everything to the square, is the same thing as x squared plus 1 squared? Taking into account this, can I say that this is true? Can I say that that's true? It's the same thing. Okay, Carlos says that it is the same thing. Natalie says no. Why not, Natalie?
It just feels wrong. I don't know. It's wrong.
It just feels wrong. Yes, this is not correct. This is not correct. Why not? Because of this. X times x is x to the square. And this is like parentheses. So this is actually x plus 1 times x plus 1. Why? Because we have an operation on the inside of the parentheses. So this x plus 1 to the square is actually the parentheses multiplied by the parentheses, okay? It is not this. If you do this, this is incorrect, okay? It is something different. Now, x plus 1 to the square is the same thing to x plus 1 times x plus 1, because we have that plus, that operation in there. Now, if we had, for example, xy to the cube and everything to the square, then we could do it. Okay, then we could do the distributive property of the power, and this was going to be x to the square, y to the 6th power. Why? Because we have a multiplication, not an addition and a subtraction. Whenever there is an addition or a subtraction inside the parentheses, you cannot do power of a power. Only if you have multiplications or a division fraction, then you can do a power of a power. If not, you cannot. So in this case, x plus 5 to the square is basically the same thing as saying x plus 5 times x plus 5. Okay, it is basically the same thing. And we could solve it just like we did it here, using the distributive property, using the FOIL method. We could do it the same way. However, we will not be doing it that way. We will be doing it in an easier way, okay? What would be the easier way? It would be with a formula, okay? We're gonna do it with a formula. We have two formulas. And the formula says that if you have a term, which we're just gonna call A, but A can stand for anything, for any monomial, plus B, which also can stand for any monomial. Okay, remember the definition of monomial? Okay, any real number, any variable, or the product between a variable with a whole number exponent and a real number, okay? So A and B are monomials. This is equal to, and this is the part that you're going to be doing, the first term of your parenthesis to the square. Since it is an addition, you're going to say plus 2 times the first term times the second term plus, always plus, the B, which is the second term, to the square. Okay? That is the formula there you're going to be using. And we have another formula that is a term, any monomial minus another binomial, another monomial to the square. This is subtraction. That's the only difference. Is going to be basically really similar to what I have over here, but instead of an addition, it is going to be a subtraction on the first sign, okay? And those are my two formulas. These formulas are called special cases, okay? This is a special case. Why? Because it is exactly the same parenthesis being multiplied by exactly the same parenthesis, okay? So it is called a perfect square. You have the first term to the square, you have the last term to the square, and the middle term is the multiplication of them both times 2. That's why it's called a perfect square. This is the sum, because it is an addition of a perfect square, and this is a difference, because it is a subtraction of a perfect square. And these are the two first special cases formulas that you are going to be learning. Now, let's copy our original exercise and let's see what do we have to do. Okay, let's see what do we have to do. And I move this. Okay, so this is my first exercise. So the first thing that I need to do is to identify the term A and identify the term B. And it is easy because the addition or the subtraction is the middle, okay? It's like the separation. So from the sign to the left, that will be A. And from the sign to the right, that will be B. In this case, it's easy because it is only X. This is A. And this is B. Okay, easy peasy breezy. Now, this is an addition. Which formula should I be using? I'm going to call this formula 1, and I'm going to call this formula 2. So which formula should I be using?
Formula 1.
Formula 1, because it is an addition. So I'm going to copy my formula down here. Since I have already my formula, all I need to do is to substitute. So that's what I'm going to do. I'm going to substitute A to the square. So instead of A, I'm placing X to the square. I'm always going to place my terms in between the parentheses. Plus the 2 of the formula times A, which is X, times B. And how much is B? 5. Plus B to the square. B is 5. So 5 to the square. Now look at this. Look at this middle part that I have over here. 2 times X times 5. It resembles to this. You see, I have the 2 of the formula. I got A, in this case, it is X, and I have B, which in this case is the 3. So I have all of the three terms in the middle. So that's why I wanted to show you this way, because it is actually in there, okay? It is just not specified at the beginning when we were multiplying binomials, because first we need to learn the binomials, their multiplications, and after that, we are introduced to the special cases. Okay, so you can see it just exists in there. So let's finish this. How much is x to the square? How much is x to the square? How much is this x to the
X.
square?
X.
X.
Where?
X what?
X parenthesis X.
No, how much is x
To the cube.
Why to the cube if that's a square?
X squared.
Exactly, x to the square is x squared because it's only the variable x. Now, we're going to multiply the coefficients by themselves first. So 2 times 5. 10. And I copy the variable x because, well, it's not a like term of nothing. So I just go ahead and copy that. Plus, how much is 5 to the square?
25.
25. And that is my final answer. If you check it and you do it with the distributive property, you will see that you actually get exactly the same answer. Now, you need to be careful with the instructions that I give you. If I say solve the special case, then you need to use the formula. If I just say multiply the binomial, then you can use the distributive property or the formula. But if I specify solve the special case, you need to use the formula, okay? Now let's go with the second exercise that it's already to the square. What formula should I use? The first one or the second one?
The second one.
The second one. So I'm going to copy the second one. And why the second one? Because it is a subtraction. Just remember that I need to be careful with that, okay? It is basically the same formula. I just need to be careful with my signs, okay? Now, I'm going to identify A and B. So A is X and B is just the number, not the sign, because the sign is already included in here. That's why we changed it from positive to negative, because the sign is already included. So B is only the number, but positive, only 6, okay? Now, how much is A to the square?
X squared.
X elevated to the second power, to the square, minus the 2 of the formula. We said that A was X, and how much is B?
6.
6, only 6, perfect, without the sign, only the 6, plus B to the square. So it's gonna be what to the square?
6.
6 to the square. And we solve it. X to the square is
X squared.
square. Negative 2 times 6.
Negative 12 squared. And
Negative
just
12.
negative 12.
12.
Then I copy the X.
X.
Plus, how much is 6 to the square?
36.
36.
36. If you do it with the distributive property, you will get exactly the same answer, but it would be easier. It will take less steps. It only takes 2 steps. It does not require much simplification, but multiplication in there. So using special case formulas is an easier way of multiplying this specific binomial multiplication, where you're multiplying the same binomial by itself. Okay, so it is easier that way. Is there any question whatsoever? We are clear about the topic. Okay, so for right now, I just need you to copy these 2 formulas and to place the specific name of these 2 formulas, which they are perfect square. Okay, the name of these 2 are perfect square. Sum of a perfect square and difference of a perfect square, but both of them are perfect squares, okay? And that will be the first 2 formulas that you are going to be having and your index card, okay? Those two are the first out of 7, plus another theorem that we're going to be learning if we have the chance. Questions? No questions? Okay, then. We're going to place the topic's name afterwards, not right now. So we just leave the empty space and the date. Today is April 29th, 2022. And that will be it for the part of the topic for today. And we're going to continue in our next class.